Alright, welcome back to the second video of curve sketching. So today we'll be sketching more complex curves, including trigonometric and exponential logarithmic functions. Last time we only included basic functions, which only included polynomials of x. So today we'll be doing something different. Alright, the graph of f of x is equal to sine x over x on the domain negative 2 pi to 0 is concave up on the interval a is less than x is less than b. Find a and b. Concave up is solving for the second derivative is greater than 0. So first we need to find the first derivative. So f prime of x is equal to derivative of the top cos x times the bottom minus the derivative of the bottom 1 times the top sine x over x squared. Alright, and now we take the second derivative. F prime prime of x is equal to, alright, derivative of the top is x cos x plus x negative sine x, and then minus cos x derivative of sine cos. Oh, sorry. And this needs to be multiplied by x squared, and then I need to subtract the derivative of the bottom times the top x cos x minus sine x, and the whole thing over x to the power of 4. Alright, we need to clean this up a bit. F second derivative of x is equal to cos x plus negative x sine x minus cos x. So these two cancel out, and there's an x term in the numerator and the denominator, so we cancel these out. Alright, so let's rewrite this. This is equal to x squared negative sine x minus 2x cos x minus sine x. Alright, and the whole thing is over x cubed. And you solve for this equation equal to 0. And the numerator is equal to 0. This equation is really hard to solve. I'm pretty sure this question is an IB question. I'm pretty sure it's from paper 2. So you can use your graphing calculator. And so what I'm going to do is I'm going to use Desmos. But on the test you're going to have to use an actual graphing calculator, but it's pretty similar. So here I've graphed the same function, and I've limited the domain from negative 2 pi to 0. And this is the function. So we're solving for the interval where f of x is concave up. So that means we need to find the interval the second derivative is positive. And as you can see, these are the two zeros that we normally solve for. But since we're already using calculator, we can directly write off the interval. So it's from negative 5.94 to negative 2.08. Oh, sorry. Alright, so the answer is concave up from negative 5.84 to negative 2.08. Alright. Second question. This one has an IB past paper code. And it's on paper 1, no calculators allowed. Alright, consider the function f of x is equal to ln x over x, and the domain is from 0 to e squared. 1. Solve the equation f prime of x is equal to 0. So f prime of x is equal to derivative of the top, which is 1 over x, times the bottom, which is x, and then subtract derivative of the bottom 1 times the top ln x, all over x, the bottom squared. And we solve for e equals 0, so 0, and we equate it to the numerator, and that is 1 minus ln x. So ln x is equal to 1, and x is equal to e to the 1, it's equal to e to the 1, which is just e. Hence, show the graph of f has a local maximum. Okay, so the domain is from 0 to e squared, and we have we have a local max or min, or point of inflection, since the first derivative is equal to 0 at e. So we can do the interval test from 0 to e, and then from e to e squared. And we do 1 minus ln x, denominator x squared, and then the whole function f prime of x. So from 0 to e, ln x is less than 1, and 1 minus something that's less than 1 is positive. X squared is positive for all values. And from e to e squared, 1 minus ln x is greater than 1. It's in between 1 and 2. So 1 minus something that's greater than 1 is negative. So f prime of x is positive from 0 to e, and negative from e to e squared. And since it goes from a positive slope to a negative slope, that means that there is a local max at x is equal to e. Write down the range of the function f. Okay, since we have a local max in this interval, that means that this is the maximum value of f, and the maximum value in the range. So we can plug in x, e for x, and we can get ln e over e, and this gets e 1 over e. So that is the maximum value of y, or f of x. And as ln x over x, when ln x approaches 0, it approaches a vertical asymptote at x equal to 0, and its value is approaching negative infinity. And since it's on the positive side of 0, x is positive, so negative over positive, this approaches negative infinity. That means that there is no lower bound for the range, and so the range is just f of x is less than or equal to 1 over e, because e is the maximum. Alright, part B. Show that there is a point of inflection on the graph and determine its coordinates. Alright, so our equation is f prime of x is equal to 1 minus ln x over x squared. So to find a point of inflection, we need to solve for, we need to find the second derivative, f prime of x. And so derivative of the top, negative 1 over x times the top, x squared. Subtract derivative of the bottom, 2x, times the top 1 minus ln x, and the whole thing over x 4, bottom squared. And then we clean this up a bit, and it's equal to negative x minus 2x plus ln x, plus 2x ln x, the whole thing over x to the 4. And since we need to solve for the second derivative equal to 0 to find the points of inflection, we just need to equate the numerator to 0. So 0 is equal to negative x, negative 3x combined, plus 2x ln x. So we can factor x, 2 ln x minus 3 is equal to 0. So x is equal to 0, but that's out of the domain because the domain is restricted. So that means we just need to solve for ln x is equal to 3 over 2. And what that means is x is equal to e to the 3 over 2. And this wants us to solve for the coordinates of the point of inflection. Right, so I cleaned it up a bit and I rewrote the x value of the point of inflection. So we plug in this value into f of x to the 3 over 2, 3 over 2. So we get, and this is equal to ln of e to the 3 over 2 over e to the 3 over 2. And this is equal to 3 over 2 e to the negative 3 over 2. So let's rewrite the coordinate. Alright, this is the point of inflection. And part C wants us to sketch and indicate the asymptote, the x-intercept, and the local max, and the local max. And on the test, they don't give you the axes. You have to draw that on your own. But for simplicity, I included an x and y axis. All right. Because ln x approaches negative infinity when x is approaching 0. So there is a vertical asymptote at x is equal to 0. And then we go up to e squared. That's the domain. And remember that there is a local max at e 1 over e, and there's a point of inflection at e 3 over 2 e to the negative 3 over 2. Okay, so we need to draw these. Oh, and also there's an x-intercept at 1, 0, because ln of 1 is 0. Alright. So this is 1, this is e to the, and this e, and this e to the 3 over 2. And let's erase this, whatever that is. Alright, so it starts off negative infinity, it crosses 0, and then it reaches a maximum at e to the 1, e 1 over at that coordinate. This is 1, 0. And then it decreases to here, and then it reaches a point of inflection. And this point is e to the 3 over 2, 3 over 2 e to the negative 3 over 2. And this is local max, this is point of inflection, and this is x-intercept. Alright, and this question just wants a rough sketch, so it looks something like this. Alright, that is the last question. Thank you for watching this short video, part 2 of the curve sketching series. Thank you for watching.